Welcome to Sim Code. Want more coding tips? Like, subscribe, and you won't miss a single video. This example demonstrates how Softmax regression can be used for multi-class classification. The goal is to predict the class of each observation in a dataset based on its features. The code takes a set of features, x, for each observation, applies a linear combination of weights and biases to compute raw scores, and then uses the softmax function to convert these scores into probabilities for each class. The class with the highest probability is selected as the predicted label. The model is then evaluated by comparing the predicted labels to the true labels, and accuracy is calculated as the fraction of correct predictions. In summary, this example illustrates how softmax regression works to classify data into multiple categories and how to assess its performance using accuracy. Sample dataset with features, 3 features for simplicity. Each row represents an observation, and each column represents a feature. Suppose this dataset has 3 observations, 3 rows, and 3 features, 3 columns. Observation 1 with 3 features. Observation 2 with 3 features. Observation 3 with 3 features. The true labels, classes, for each observation, for example 0, 1, or 2 for 3 classes. This tells us which class each observation belongs to. Observation 1 belongs to class 0, observation 2 to class 1, etc. We have 3 classes, so initialize a random weight matrix for 3 classes. The weight matrix has dimensions, 3 classes x 3 features. Each row in the weight matrix corresponds to the weights for one class. Bias term for each class, 1 bias for each class. Bias allows the model to shift the decision boundary for each class. Each class has its own bias value. Function to compute the softmax probabilities. This function computes the softmax of the input scores, logits. Softmax converts the raw scores, logits, into probabilities that sum up to 1. Each probability indicates the likelihood that the observation belongs to each class. Exponentiate the scores to make them positive, and then normalize by dividing by the sum of exponentials. Exponentiating helps with making the values positive and large scores more impactful. np.exp calculates the exponent of each score. Normalize by dividing by the sum of exponentials. Function to predict class probabilities for all observations. This function computes the predicted probabilities for each class and observation. X. The input features, observations, of shape, n_ samples, n_ features. Weights. The model's learned weight matrix of shape, n_ classes, n_ features. Biases. The bias values for each class, with a length of n_ classes. Calculate the raw scores, logits, by multiplying features with weights and adding biases. np.x weights.t performs matrix multiplication between x n_ samples x n_ features and weights.t n_ features x n_ classes, resulting in a matrix of raw scores of shape n_ samples x n_ classes. Scores represent the raw predictions for each class. Apply softmax to the raw scores to get probabilities. Transpose scores to ensure softmax operates across classes, axis 0. Predict probabilities for the dataset using the model's weights and biases. Print the predicted probabilities for each class. Now let's get the predicted classes based on the highest probability for each observation. np.argmax returns the index class with the highest probability for each observation row. Print the predicted classes. Evaluate the model. Compare predicted classes with true labels. NP.mean calculates the accuracy by comparing the predicted classes with the true classes. Compare predicted versus true classes and calculate accuracy. Now run our code. Hey everyone! If you're enjoying the content and learning something new, don't forget to hit that subscribe button and like this video. It helps out the channel a ton and make sure you don't miss any future coding tutorials, tips, and tricks. Your support means the world to me and helps keep the content coming. So go ahead, smash that like button and subscribe if you haven't already. Thanks for being awesome. Let's get back to coding.